Hello everyone, I am Necmettin Gedikli and today I will make a presentation about process control block as you can see here. In this presentation we will learn about process control block and its features and let's start our presentation. Process control block is a data structure and the operating system stocks all the information in process control block about the process. When a process is executed in operating system, the operating system creates a process control block for that process. It has so many features such as assigning ID to processes, which is process ID, setting the state of the process, which is process state, and determining the priority of the processes, which is process priority, and so on. And let's see a diagram about process control block and try to figure out its features. As you can see here, there is a whole PCB. You can say PCB, and each stages of PCB have different features, and when we compound them, we will get this. These stages are process ID, process state, process priority, accounting information, and so on. And let's get the process ID. This first part of process control block, which assigns ID to processes, when the user creates a new process, the operating system assigns a unique ID to that process. The assignation of ID starts from zero. That means the first process in operating system will have ID 0. There's a limit for processing. When the user reaches the limit and still creates a process, the operating system will terminate the process which has ID 0, and this ID will be given to new process. And that is one of the layers for assigned ID. And there is another one which I didn't mention. Uh, the operating system can assign ID to process control blocks. I am repeating, process control blocks, not processes. When a process will pick a process control block, this process will take the ID which same as the process control block. About process state, a process can be in different states. These are, as you can see here, new, ready, running, block or wait, and termination. When the user executes a process, that process may be present in one of the five states. As let's start with new one. This state includes the processes that are ready to be loaded by operating system into the main memory, which is RAM. For ready state, this state includes the processes that are ready to be executed and already in main memory. The operating system brings these processes from secondary memory, which is hard disk, to main memory. These processes are known as ready state. Running state, it includes the processes that are currently executed by CPU in operating system. Block or wait, a process that is running may be switched to block or wait state. It depends on the behavior of the process or schedule. And the last state, termination, a process that is completed its execution will be in termination state. All the contents of this process will be deleted by operating system. The process control block of this process is also included, and let's see a diagram about this. It starts from new, it goes to ready, running, it can be in waiting state, and it can be ready again. And when it reaches to terminated, all the contents will be deleted for this process. So process priority, as you can see, it is a value that determines the priority of the processes. Smaller values mean more priority of the process. The operating system determines the priority at the time of the creation of process control block. It depends on many conditions like the age of the process, etc. And the priority also can be determined by assigning. Program counter, as you can see here, this qualification of process control block is a pointer that points the next directive in the program to be executed. It includes the address of the next directive to be executed in the process. Uh, when we come to CPU registers, the specific registers which are being used by specific process. When the next process is executed, this process which gets the CPU will remove all the temporary data that are different. There are different kind of CPU registers, such as we can say stack pointers, general purpose registers, index registers, and so on. And the CPU scheduling information, it keeps the information that is needed for scheduling. It has the priority informations, scheduling queue pointers, etc. It is also stored in process control block. Memory management information, it is also stored in process control block. It symbolizes the memory which is being used by specific process. Accounting information. This qualification gives information about the resources that is consumed in time of the process execution. For example, we can say connection time, usage, CPU, memory usage, and etc. Input output status information. The last part of process control block, as you can see here, it has the list of the input output devices that the process can use while its execution, and the information of input output devices are stored in IO status information. The processes can use these devices. Yeah. When we put them together in order, we will get process control block. And so this is the end of the presentation. Thank you for listening.